Hello everyone, welcome to my channel. As a part of the series Programming SIWG917, in this video we will be interfacing button and LED and displaying which button has pressed on virtual terminal as well as onboard MEMLCD display. So if you refer to the user manual of BRD 4338, you can see we have two buttons, button 1 and button 0, as well as LED 1 and LED 0. So what our requirement says is we have to interface button and LED and display which button has pressed on the virtual terminal as well as on memory LCD. So our uh, task is to check which button is pressed, and also once you have checked it, you have to display it on virtual terminal as well as on memory LCD. So without any delay, let's start our programming. Open Simplicity Studio. As we have created a project in the previous video of blinking an LED, in the same way, now if you observe what all we need are, for our use case, what all we will be needing is, if you observe, interfacing a button. So we need something with related to button program, and button plus LED program we will be needing. And apart from that, it is asked to display on virtual terminal. You have to always remember that whatever the thing you are displaying as a debug message, like if you are messaging, if you are printing something like debug out Shiva, so this debug message will be sent through serial wire debug. So the serial wire debug as well as virtual comport. So you can view this message in both VCOM as well as SWD. So if you want to send a message through virtual terminal, you can directly send it through debug out. So that's not a big deal. And the third most important thing is memory LCD. So we need MEMLCD. Once you have finalized with what you will need in order to combine and get this project done, you can move to Simplicity Studio, and you have to create projects, file, new, Silicon Labs project wizard. In this, you will be choosing a project. First, you will be choosing a board. Click on next. And here you will be choosing a button program. Let's see if it is available. Yeah, it is available. So you can click on next. Uh, it's better to rename it to something very understandable. So you can rename it to button underscore memlcd and click on finish. Once the project is created, you will be popped up with the readme file of the project. You can ignore it and proceed for next project creation. So you can see readme document and SLCP document are popped up. Now the second thing we need is the memory LCD. You can file new Silicon Labs project wizard, and you have to verify the board details. Yes, these are the boards that we are using, and click on next. And now here you have to use MEMLCD, memory LCD. You can click on it and click on next. And let this be as MEMLCD bare metal, because we will be using this MEMLCD many times in for further videos, and click on finish. So once you have created both the projects, which is button underscore MEMLCD and MEMLCD underscore bare metal, uh, the second thing you have to do is to merge these projects. That is, let us say, if let us first open the button ka app.c or slcp. It is better to open button slcp, and then you open memlcd slcp. You can go to software components, right click on any of it and click on expand all. In memlcd also you do the same thing, software components. Once it gets loaded, right click on expand all. So you just scroll through this, and see, if there is a tick, that means that component is included into the project. you find such components, you just randomly pick a count. So I have found 1, 2, and 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and then 21, 22, 23, 24, 25, and yeah, it approximately 25 components are there. You can go to button underscore memlcd underscore app, so you can count these as well. Same thing, whichever is there a tick, you have to count those. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So approximately 25. But when it comes to the app.cs of both the files, so if you go to the app.c of button bare metal, you will find something known as button process action. You can click on it. So as this is a bare metal program, you will barely find header inclusions or configuring OS clock. But if you are merging a program like pinging a server or something which is not a bare metal program, it will have many initializations and headers. So if you want to merge that program with your memlcd, it's better to copy the contents of the memlcd program into the uh, non bare metal program. In my case, both are bare metal. So what I'll do is, first I have to copy the contents of memlcd into this button bare metal. So before I do that, I want to tell you few important note points. So we have already formulated that we will be needing button plus led program and memlcd program. But after getting these programs, what you have to do? So this button plus led, obviously according to the readme file, if you press button 0, led 0 will be glowing. So for this functionality, you have to add an additional functionality that along with button 0, if button 1 is pressed, you have to glow led 1. Once you are done with this, one more additional functionality will be maintaining flags like flag 1 and flag 2, whose status will be similar to led 0 and led 1. So you can have flag 0 and flag 1. So the status of flag 0 and flag 1 will be similar to the status of led 0 and led 1. So these flags will be sent to the memlcd function, and in the memlcd function, based on the value of flag 0 and flag 1, you will be displaying so and so button is pressed, so and so button is pressed, or so and so led is glowing. You can display such kind of things. And for vcom, you can directly throw the debug messages. So our current task will be, first we will be putting all the memlcd slcps into this, and then we will be adding this button 1 plus led 1 functionality, and after that we will be moving into the flags section. So first let us copy the memlcd code into the buttons section. I'll tell you how to do it. So for that, what you have to do is, you have to open both the slcp files, and as mentioned earlier, you have to click on expand all. You have to check them part by part. Like for example, benchmark. Under benchmark, nothing is there, nothing is there. Under utility, you have nothing in the memlcd, so you need not go there. You go there and check if anything is missing. So if you have any tick here, for example, you have a tick here, see, you have some tick here, that means that component is already installed. So under platform, under mainboard, there is a tick. You have to go to button program. You have to check for platform. Under mainboard, BRD4002 has a tick. So that means whatever is there in the MEMLCD side, it is already there in the button. So in this way, you have to check each and every section and copy the content. How do you do that? For example, in board drivers, we have monochrome sharp LCD in the MEMLCD display, sorry, MEMLCD display program. But here we don't have that monochrome sharp LCD. How I am telling we don't have, in the button program we don't have anything like tick here, but in the but in the MEMLCD bare metal we have something like tick. So what you have to do is you have to click on it and click on install. This install thing you have to do in the button program, because we are trying to push all the MEMLCD and functionalities into the button program itself. So now you have to go back and move a little bit up and start checking again. If you find anything, you have to go back and add it. So CMC score will always be enabled. CMC score and common APIs for CMC's compliant kernels. C, graphic library driver and graphic library headers. So this is under the driver. Under LEDs we have it. So you have to go to drivers. Uh, yeah, device drivers, LEDs. C. This is not installed in the buttons program. You have to install it. You'll get yeah, this is the thing you will be installing, because this has a dependency, so it will automatically install the dependency as well. Once you are done with this, both of these will be getting installed, and you have to move back to the MEMLCD and again keep on checking. So if you find anything, you have to go back and add them. So you understood the adding process, right? So you have to repeat this. So you can see under status code definitions and GCC tool chains for ARM. These all were there. So I have to go back. I have to scroll down. See, those all are already included. So if you observe here, atomic operations library is there in MEMLCD, but it is not there in the button. So you have to click on atomic operations library, install. Yeah, it is installed. Now once you're done with it, you have to go back and again start verifying it. So core is also being installed in MEMLCD. It is not installed. You have to click on it. You have to click on install. Once it's done, you can scroll up, scroll up. So we have system setup here. Check for system setup. Yeah, it is also been ticked. You have to scroll up and you can see under Wise Connect 3 SDK, you have common flash component installed in MEMLCD. So you can directly move to the Wise Connect. You can collapse this third party, Wison, Z-Wave, Zigbee, under Wise Connect. So you have common flash component installed here also. You can go back to MEMLCD and start checking again. So you have SIWX stack configuration system cells and all. So everything is enabled. NVIC interrupt priorities is also enabled. UDMA linker configuration, that is also being enabled here. So no external flash. Yeah, that's also being enabled. Yeah, here we have something called memory LCD spy driver. So that is not being enabled here. So yeah, that is also being enabled, sorry. So once again, what we have to do is, if you remember, we also need button 1 and LED 1. So for that, you have to click on button 0. Here you have add new instance, click on it. Button 1 will be recommended and click on done. Once you are done with it, you will be seeing another button under button 0 here. See, and the same with the LED 0. Click on it, add new instance. It will be recommending LED 1. If not, you only type LED 1 and click on done. Once it is installed, you will be seeing LED 1. Yeah, that's what it is. And you have to come back and start checking again. No external PS RAM. And if you move down, uh, Under ULP timer, we have timer 0 in MMLCD, but in button, we don't have anything in such. So under ULP timer, so if you see, we have DMA here, but we don't have DMA here. You have to click on DMA and click on install. DMA will be installed, and then what all GPIO, SSI. So these are some things we don't have. SSI is not there. You can click on install. Once you are done with installing it, you can see under ULP timer, timer 0 is installed here. You have to click on ULP timer and install. It will ask for instance name. There also it is given as timer 0, so you can directly add as timer 0. Once you're done with it, it will be added. So you can scroll down and check if anything else is left. So you can see under ultra low power, sleep timer for SI916 is enabled. So you have to go down and check for ultra low power where it is there. I think we lost it. Yeah, ultra low power. Under that we need so you can see sleep timer for SI91X. Click on install. It will be installed, and again go back to MEMLCD and start scrolling again. So default ROM and memory, these are already installed. So check SN91X FreeRTOS configuration. SN91X FreeRTOS configuration is installed. You have to check every software component thoroughly, or else you will be left with errors. So everything is done. Whatever there in the MLCD is being copied into the button program. Once you are done with this copying of the software components, you can close this .slcp file and .app.c and button bare metal file. Now what you have to do is you have to open app.c of button bare metal as well as memlcd. So in memlcd app.c, you can see memlcd app underscore init. You can click on it. It will take you to a memlcd underscore app.c. There you have a function called memlcd init, which is responsible for displaying text on the devices. So this is the file that you need to copy into the button program. So for that you have to go to the app.c of button, and there you will be seeing something like button.process action. Left click on it, control click on it, hold control and click left click. So it will take you to a button underscore bare metal.c file. There you have to scroll up. Here you can see all the libraries are included. You have to go to memlcd underscore app.c and copy all the libraries present here and paste it near the libraries. I repeat, place it near the libraries. Okay. So once you have included, if there are any errors, those will be popped up here. So I think all those have been included properly. So we are not seeing any errors because we have included all the .slcp files. And once you are done with this copying this, you have to copy the hash defines next and place it near the hash defines only, just to maintain code integrity. After that, you have to copy the static variables, and yeah, here you have static variables as well. So yeah, you can include here, or unused declaration, it's okay because we didn't copy the code yet. So this is the main program that you need to copy, and once after copying, you have to paste it, better to paste very first to the code. So let us also add command lines. memlcd interfacing code, or better to use the name function for interfacing memory LCD. So if you observe here, we have something called void memory LCD underscore app underscore init of void, but we want something to be passed to this function for displaying. So let me change it to simple int k. Let me keep it as k. So inside the function, what needs to be processed, we can check it later. So the next part, what we have to do is we have to add the functionality of another button and another LED, which is button 0 and LED 0. For that, what you have to do is you can see if in def LED instance LED underscore LED 0. So if you scroll down through code, you'll have something called as button process action, and in the button ISR you have some pin and state. If the button state is pressed, you will be toggling the LED, or else you'll be not toggling the LED. So for that, what you have to do is so if you observe this function, what we have is if pin is equals to button instance dot pin, if state of button is equals to pressed, you are toggling LED instance dot pin. Now what I'll do is I'll add another instance. So you can copy the if and if and create a space, and what you do is button instance 1, you name it as button instance 1 and keep it to button instance button 1. You copy the LED and enter, you paste it, and you keep it LED instance 1 and LED instance 1. Now what you will do in this function is instead along with checking if pin is equals to button instance 1 dot button instance pin, you can simply copy the whole thing, this if wala, and along with this, and you can just simply replicate it down with adding 1 to everything. Button instance 1 dot pin, button pressed, and so I forgot to tell you, while you are including not only if and def, this define also has to be changed. So for that reason, just now we got a bug here. So we have copied this whole thing here. Now you are checking pin with button instance 1 dot pin, and if state is equals to button pressed, you need to toggle the LED. Here LED underscore instance dot pin, instead of that LED underscore instead 1 dot pin, and else here also you have to change it to LED underscore instance 1. Once you are done with it, you can for checking purpose, let us keep this to void for now. And what I'll do is I'll just save this code, and I'll dump it onto my board, button underscore MEMLCD. Let's see if we get any errors. So if you can see, we have 0 errors and 0 warnings. The code is being dumped onto my board. So let me check the functionality. Yes, the code is functionally well. If I am pressing button 0, LED 0 is glowing, and sorry, LED 0 is toggling. For button 1, LED 1 is toggling. So that's fine. Now the second part is integration of memory LCD. For that, what we will do is now let me have two flags here. Let me maintain some local variables here, or global variables. Better to keep it as global variables, and yeah, let me maintain it just before my function. I'll call them as local to my function, or global variables. I'll maintain int flag 1. I'll assign it with 0, and int flag 2. I'll also assign it with sorry, for clarity I'll keep it as flag 0. I'll also assign with 0. Once you are done with it, I'll change it to int k, let us say. Okay. uh, or instead you can just keep it as void, and monitor the flags, because it is better to monitor the flags. It is already global, right? So you can write a code in this, something like if flag 1 is equals to 0, or yeah, if flag 1 is equals to 0, mm, you can keep these flags as -1 instead. So if something or 0, yeah, good, that's good. You can, if flag 1, you'll display button 1 is pressed. So you'll copy the whole thing, and here you'll paste it saying, instead of this string you'll say button 1 is pressed, or button 0, let's say button 1, let it be button 1 for clarity. And then if flag 0, you have to say the same thing, but instead of button 1, this time you will be saying button 0. So yeah, you can just remove these things. And also, to eradicate unnecessary loss of text, you can divide current line with modular division 12, so that the text won't go beyond the lines, making some mess over there. So once after you have displayed this thing, it is always important to reset your flags. Not only in this application, but in any embedded application, resetting flags is very important. Flag 1 is assigned with, flag 0 is assigned with original state, which is -1. So, or okay, sorry, original state is 0. Now in this code, what you have to do is, if state is equals to button pressed, here you are sending toggle, right? And what you have to do is, you have to also send memlcd underscore init of, sorry, memlcd underscore app dot init of. So you can just copy paste the function name, and before calling the function, what you have to do is, here you are checking for button 0. So you have to make flag 0 is equals to 1. In the same way, you can copy this thing and paste it over here, and instead of flag 0, this time you will keep it as flag 1. Flag 1. So this is all we have done. What we have done, we have changed, we have maintained two flags, flag 1 and flag 0. If flag 0 is 1, in memlcd it will be displayed as 0 button is pressed. So if flag 0 is 1, button 0 is pressed. If flag 1 is 1, button 1 is pressed. That is what we have written code. So you can simply save the code, save it, and click on the function run as Silicon Labs ARM program. Select your board, click on OK. Wait for the compiler to compile all the lines of code that you have written. You can see there are no errors. It is being copied onto my board. Yeah, it is copied onto my board. So let me see, let me check it once. There is some error with this with our design. Let me check it once. So we have copied everything. Uh, in memory LCD also, we have copied almost everything. Yeah, we have to call this memory LCD app dot init. So let me once check it with just commenting out the function call of memory LCD. So if you observe, like according to my observation, both buttons and both LEDs are working fine. But if you are interfacing memlcd along with them, it is causing issue. Now let me try for single button, like if it is working for single button or not. First let me try with the button 0 and LED 0. Let us keep this as normal, and let us comment out this part of our code until this line. and then I'll be running it. So you can see there are no errors. The code is being copied. So we had button 0, right? So even button 0 is not working. So now let me try with button 1 instead, button 1 and LED 1 combination. For that I need to comment out this part of the code and then remove the comment for this part. You can save it or you can directly run it. So you have to go right click, run as Silicon Labs ARM program. Yeah, now button 1 is working. Let me remove the comment for MEMLCD. So run as Silicon Labs ARM program. Okay. Now after this, let me check with yeah, this is being copied. Uh, yeah, button 1 and LED 1 combination is working, but button 0 and LED 0 combination is not working. For that, previously we have faced this kind of issue. The issue we have found out is LED 1 is corresponding to the Cortex M4 peripheral. Let me show you. So if you observe here in the page number 3, you have something called user LEDs, LED 1 and LED 0. Now according to us, the problem we are facing is because of LED 0. Let us copy this LED 0 and check where it is connected to. So if you observe, it is connected to F11, radio F10 and radio F11 LEDs are connected to. Now we need to go to the schematic of BRD4338, which is our radio board. So you can directly move to the connectors page. Yeah, here if you can see, you have your UAF LED 1 connected to normal GPIO pin, which is GPIO 9, sorry, GPIO 10. And whereas your UAF LED 0, it is connected to UAF LED 0 is connected to the ultra low power section of the GPIOs, and also your button 0 is connected to the ultra low power VBAT section of the GPIOs. So what my guess is, there might be some error with using ultra low power along with Cortex peripherals together. So if you are interfacing both of them together, it is better to stick for one button and one LED and memory LCD and all. So the only thing left now is sending out VCOM signals that you can do directly here itself. You can open a normal flower braces, and inside the flower braces along with the same message you will be uh, sending a debug message also. So debug out of whatever there here, you'll be copy pasting the same thing here also. Yeah, same debug out of control V. Here you will be changing 1 to 0, and once you are done with it, you can save it and run it once again. Save, run as Silicon Labs ARM program. Wait for the code to compile and to be dumped onto the board. For some reason we are getting an error if we are calling debug out in this inside the function. So it is better to have debug out outside the function. So you can cut one thing, and you can simply undo everything what you have done, and the place where we are calling this function, there only let us keep the debug out function. So here what we are checking for, we are checking only for debug out of 1, right? So you can keep it here and save the file. Still we are getting some error, so let us simply keep it as printf instead of debug out. Printf. So debug out is also nothing but internally it will use printf statement only. These all printfs will be printed on the launch console of our debug adapters pane. So you can check which is the error you are. So the error we are facing here is regarding the bare metal program, because in bare metal program they didn't include anything related to debugging. So let us have something like hash include stdio.h, but I think it won't help us. stdio.h, if it exists, hope so. You can click on run as silicon lab sam program, choose the board, click on ok. So finally, what we have missed out is we have missed out to include rsa underscore debug and dot h, which I have included now. So you can see I have included rsa underscore debug dot h. So once after including, you can remove this stdio dot h. So I have removed the stdio dot h, and so in our desired functionality we have done everything. uh, we have displayed it on MEMLCD. We have interface two buttons and two LEDs, but unfortunately we are unable to interface both the buttons at a time, because one cortex and one ultra low power, maybe there is an issue with using both of them at a time. So this is all for this video. Thank you for watching. If you like the content, please do like, share and subscribe to my channel Tech Talks. Thank you.